line mark. So it's an imaginary line. So anything beyond that 100 kilometers. Actually, why Karman line? I will come to that later. 100 kilometers from the surface of the earth is said to be space, right? So that you people all understand, right? So that you people all understand. Outer space begins with so by definition, habitable airspace illa, and there is no atmosphere to scatter light even. But the basic question of space is very dark. Light basically we see objects and we see light because the rays are scattered by particles. So beyond the 100 kilometers, it becomes very thin. In theory, once this 100 kilometer line is crossed, the atmosphere becomes too thin to provide enough lift for conventional aircraft to maintain flight. Conventional aircrafts fly in the aircrafts fly in a fighter 10 kilometers is a good answer, yes. Supersonic fighters and military aircrafts can fly a little bit higher, but we have got to have special capabilities for that in terms of the machine plus the man, okay? And at this altitude, a conventional plane would need to reach and sustain orbital velocity or else risk falling backward. But why we are all staying put on this surface of the earth? Gravity. So if you want to get out of this earth and go into free space, you will have to overcome gravity, right? Yes. So escape velocity is what we are talking about in this context. So if somebody wants to go to free space, that is go to 100 kilometers beyond and stay there, staying there, don't want to come back, you want to stay there. In that case, you should have to achieve escape velocity or sustain that velocity with which you continue to revolve around Earth. If there is a satellite, you just keep rotating around there, that's called orbit. So by definition, below this line, space belongs to each country. Above this level, there would be free space. But you might be hearing free space, you have to blame. Free space is belonging to the humanity. Airspace belongs, that is the space 100 kilometers, below 100 kilometers. Whatever space in India, India is a country, if you take, the space just above our country, 100 kilometers belongs to us. Beyond that is free space. That belongs to everybody. Somebody wants to come in. Now, you are talking about tropospheres. So this is the way the upper atmosphere is structured. You have 0 to 12 to 18 kilometers is troposphere. Beyond that is stratosphere, 11 to 50 kilometers. Mesosphere, 50 kilometers to 80-90 kilometers. So this is the area where the meteorological rockets and other things 0.5 degrees centigrade. Other areas also it's the atmosphere, and beyond that is, so if you look at this, there are various spheres which stretches into stratosphere, here is a mesosphere and beyond, you can say. Thermosphere and beyond is the real space. So this is the Karman line vision. The Karman line is basically an attempt to define a boundary between Earth's atmosphere and outer space, and offers a specific definition set by the Federal Aeronautical International FAI, an international record-keeping body for astronauts. So actually, every definition, there are some legal to set the rules and regulations. So what Karman line does is, you bring in some sort of regulation within which you operate. It becomes some legality. It is named, this one is that Karman line gets its name from Hungarian-born aerospace pioneer Theodor von Karman. World War I, the engineer and physicist worked designs for helicopters among other things. So there was one great Hungarian-born aerospace engineer named Theodor von Karman, and he only propounded the concept that look, beyond 100 kilometers is going to be free space. You need special skills to go out there and sustain there. Okay, so that is the rule. And while we need Karman line also, I said we have that 1967 Outer Space Treaty saying that space should be accessible to all countries and can be freely and scientifically investigated. That means the space belongs to the humanity. It is called global commons. That means the commodity that is to everyone. It is not belonging to America or US or Germany or any country. It belongs to everyone and the humanity. So by the 1967 treaty, the United Nations brought space into the global perspective and said that the space and regulations. So defining a legal boundary was very Harman line brings in that concept, right? Now you will be all wondering, where do satellites operate? We are launching so many satellites. PSLV Mark 3 is going. PSLV, GSLV Mark C53 has launched 50 satellites, 100 satellites. What happens and where do they go? So I just thought that I will bring that this one into you. You can see that how the orbits are there. Okay, fine. You are geo is at so that's why geo is. You know that 24 hours it makes one convolution around its and embodied with sufficient velocities, with which it will have orbital duration of 24 hours. So Earth is rotating, the satellite also is rotating there. So you imagine about a highway. The space is the highway, and the Earth is one of you, and the satellite is another person on in the same highway. Both are on bicycles, right? So if two friends are riding on a highway and you are having the same speed, can you speak to each other? Right? So long as you continue to speak, continue to ride with the same velocity, you can always talk to each other, right? This is the concept of geosynchronous communication satellite. So this is geosynchronous orbit. This is a inclined orbit. So this is again an inclined orbit. Inclined orbit means equatorial orbit and inclined orbit is some satellites is 400 to 2000 kilometers. Medium Earth orbit is defined as 8000 to 20,000 kilometers. You heard about our Navig satellites, IRNSS satellites. You heard about the GPS? Yes. What is GPS? So, similar to the global positioning satellite system, India has developed its own satellite system. Are you aware of that? Yes. So, it's called IRNSS, right? So, IRNSS satellites, some of the satellites are flying in orbit 8,000 to 20,000 kilometers. GEO is 35,786 or 36,000 kilometers, and there are different classes of orbits as well. This is basically to tell you what is up there in space and what is happening there, right? So why space? This is the question. So what of space is understood, right? So space begins where? 100 kilometers beyond the Kármán line, that is the point. And space ends into infinity, but for our practical purposes, space can stop somewhere near 14,000 kilometers because we are talking about geosynchronous orbit, which is 36,000 and above. So let us stop there for the practical purposes, right? Now why space? Why space is so important? Why we have to depend so much on space? So that tells you the reasons why we have to think about sustaining space. So in the modern day life, everything, whether you are in you are talking about satellite communication or corporate networks or maritime communications or satellite on the move, health, education, anything you communication, navigation, you don't know, you may not be feeling it, but in the background, satellite enabled infrastructure is out there in space. How do you get the radio broadcasts and how do you get the television, Doordarshan and other multi-channels coming to your houses? Have you any time thought about that, where it is coming from? It is coming, and satellites, there are n number of satellites, multiple satellites launched by all the countries. For India specific operations, we launch ISRO is launching satellites, building satellites and launching them. Some of them belong to the geosynchronous class, some belongs to the remote sensing class, some are in the alternate class like IRNSS, I said, they go to some other orbits. So everywhere in today's life, knowingly or unknowingly, satellites are present or space-based systems are present. Even some of these health-related new technologies have basically come out of the development that has happened in space. So space is very important. So, okay, this is just basically to tell you what all we can do: satellite radio, corporate networks, maritime communication, cellular, telemedicine. So many applications are there. So what I am trying to tell you here is from just run of the mill space-based systems, space-based critical infrastructure. So like whatever is we are having in the ground today, like electricity, transportation system, road, rail transports, no, and all the other facilities happening on Earth here, we are enjoying every day. Space also has got invisible to you. Infrastructure is happening up there in space in the form of satellites, remote sensing satellites, communication satellites, or GPS. Or recently you might have heard about Elon Musk launching so many Starlink satellites into free space. So the huge infrastructure up there in space. So space has become now indispensable in day-to-day life. That is the reason why we have to make space sustainable. Or what and why of space? Sure. So this is to show that this is from NASA. I have taken out some. So a total of 135 space launches, historical record, were conducted in 2021. This is a published NASA information, National Aeronautical Space Administration. The 135 launches placed more than 1,800 spacecraft in the Earth orbits. അതായത് ഈ 2021 മാത്രം all over the globe 135 launches happened. It could be PSLV, GSLV or any other launch, SpaceX ആയിരിക്കാം, Falcon ആയിരിക്കാം, other European Space Agency launch vehicles ആയിരിക്കാം. 135 instances of launch has happened and more than 1,800 satellites have been launched into space. ഇതിനെപ്പറ്റി അറിയാമായിരുന്നോ? ഇത് നമുക്ക് ആർക്കും അറിയാത്ത കാര്യമാണ്. നമ്മൾ എപ്പോഴും പറയുന്നു PSLV Mark 3 has launched 50 satellites. What happens to those satellites? They are up there in space. Most of them will work for 5 years, 10 years. Some new generation satellites are working for 15 years. So space industry also globally now, the current day, what we are getting our success is by virtue of how much money we can generate out of anything, any enterprise. If you are into business, you want to know how much money you can earn over this much investment. Similarly, now space industry also is coming. From the old days of scientific exploration of space, space is indispensable for us. Okay? So space industry valued at the US dollars 360 billions. Billion എന്ന് പറഞ്ഞാൽ എന്താണെന്ന് അറിയോ? ദശകോടി അല്ലേ? ദശകോടി US dollars ആണ്. അത്ര 360 ബില്യൺ US ഡോളേഴ്സിന്റെ ഇൻഡസ്ട്രി ബിസിനസ് അക്യുമൻ ആണ് ഉള്ളത് സ്പേസ് ഇൻഡസ്ട്രീസിൽ. Be it launch vehicle or infrastructure or satellite building or services that emanate out of space. It was in 2018 360 billions and it is growing at a cumulative average growth rate of 5.6 to 6% billions of US dollars. That means that much of revenue is going to come out of space. So space has become so critical. Then you've read about the commercial aspects of space. If you come to the United Nations objective of goals, that's purely based on how space can enhance the comfort levels of common man on this mother earth, either through communication medium or through remote sensing or through health and education. Whichever way, space can enable the betterment of the living conditions on mother earth. So that is one important aspect of the S for SDG is space for sustainable development goals. The United Nations has identified 17 sustainable development goals, and you can have access to it. The largest event happening right now, more than 1,500, I think more than 6 celebrations across the globe, and more than 100 plus countries are celebrating. Of course, technology saga of the 20th century, the 91 mode is the most benchmark event, the breakthrough technology demonstration of the 20th century, and as the first person landed on the moon, that's one small step for man, giant leap for mankind. Trying to say is, from those days of better than you, those days are, see, the commoditization of space has happened in a big way over the years, and space has emerged. So you can see here. So this is the commercial activities. The civil is the government. non-government, non-defense governmental agencies, research happening in ISR and other agencies, exploration, skill scientific exploration is happening. And if you come to commercial side, you have got producer services, private enterprises, Elon Musk is there, everybody is into commercial domain. And some of these private satellites who are giving you services at cost, data services, you name anything, space-based services, companies there. And in between is national security applications, which generally public will not be aware, but national security also is being addressed in a big way using satellites. Some of these surveillance satellites, no? See, what is the beauty of space? Beauty of space is that, see, you have got a vantage point up there in the sky. Somebody is watching from the, see, if you are going to, on a high-rise building and look around, you can see a better view of the city, no? If you want to have a better view of Marine Drive, what you do is go up and take precise photographs. The beauty is that without the person being watched, knowing, people can go and take snaps. That means if I want to take a photograph happening beyond Himalayas, China is our good friend, you know, right? He's a very good friend, you know. We have got friends all around. So if you want to look those people without them knowing what's happening, a satellite can be found there, right? Civilian, commercial, national security, defense, C4ISR is computers, communication, command, so many things are there. Intelligence, surveillance, recognition, you cannot, and later on when you get into some of these organizations, you should know. Intelligence, all those things are there. So we are coming to how commercialization happens and how much revenue is being generated there. Now we are telling what is sustainability. സുസ്ഥിരമായ സ്പേസ് എന്ന് പറഞ്ഞാൽ ബഹിരാകാശം സുസ്ഥിരമായിരിക്കുന്ന ആവശ്യകതയെ പറ്റി നമ്മൾ സംസാരിച്ചു. Now in one sentence it is preserving the usability of outer space. That is sustainability. If you go into definition, you know what really the sustainability is. By definition, ensuring that all humanity can continue to use outer space for peaceful purposes and socio-economic benefit now and in the long term. അതായത് ഇപ്പോൾ നമുക്ക് സ്പേസിൽ പോകാൻ പറ്റണം. അത് സാധാരണ ജനങ്ങളുടെ ആവശ്യങ്ങൾക്ക് വേണ്ടിയിട്ട് everybody across the globe should be able to reach there in space. That is what is sustainability. The current use of space should not negatively affect the potential benefits derived from the future use of that space. That means whatever space objects are there, they should continue to work there. പുതുതായിട്ട് നമ്മൾ സിസ്റ്റം ഡെവലപ്പ് ചെയ്ത് അങ്ങോട്ട് വിടുവാണെങ്കിൽ ensure that that system will not interfere with the already operational system. അപ്പോൾ സസ്റ്റൈനബിലിറ്റി സുസ്ഥിരത എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഫ്യൂച്ചർ മാത്രമല്ല, കറന്റ് മെയിൻറ്റെയിൻ വാട്ട് ഇസ് അവൈലബിൾ ടുഡേ ആൻഡ് മേക്ക് ഷുവർ ദാറ്റ് that facility of going out there by everyone concerned, whomsoever is interested, is maintained. That is sustainability. Of course, it's all bound by the 1967 treaty. So, securing space is intrinsically tied to protecting time. So, we are coming to the debris problem. You heard about debris? Space debris? So, this and all, I will skip it because of time. This one will come to. Okay. So, if you want to sustain space, there are multiple approaches. It's all coordinated by United Nations because space is a common commodity, and across the globe, which is the agency coordinating all the activities, make that as humanity holds together, United Nations. So, United Nations is taking the lead in putting this together. So, there is an office called UNOSA, United Nations Office of Outer Space Activities. Then the agency called Interagency Debris Coordination, IADC, the Space Data Association, which are the agencies who are trying to monitor and regulate these free space activities. And the other thing is mitigation efforts. Mitigation efforts is what? Already debris is created because of the malfunctioning or misfunctional spacecrafts or other bodies. Launch vehicles also, when they go, no, there will be some the second stage separated, third stage separated, like that you might have heard, no? But as the stages go, some will burn out, some will stay there only, and remember they are moving with enormous speeds. A satellite at 500-600 kilometers, low Earth orbit 500-600 kilometers. You count one, I will be next point will be 9.5 kilometers from there. That is the speed at which the satellites are moving there. And if you go farther, because of the gravitational pull effect is coming down because of the distance involved. There, no, the velocity is decreasing, but geosynchronous orbital belt of 36,000 kilometers. One satellite moves at the velocity of 3.3 kilometers per second. 3.3 kilometers per second. The huge bodies of satellites, no, you just imagine they are moving at such enormous speeds there because it is synchronized with Earth. So what I'm trying to make a point is such objects, even for a small speck, for a small paint fleck that has come out of a launch vehicle or a small body part, of a pebble size, or a marble, other size of an object, if it hits some of these working satellites, it can lead to catastrophic effects on two counts. One thing is that where free space it is moving at with some regulated speed. Somebody hits means uncontrolled. There is no friction out there in space, so there is no opposing force there. So it can be very crucial, just changing the total mission perspective or mission objectives, or it can permanently damage. If somebody hits a solar panel, it can disintegrate. In that process, the power generation can be crippled, and in that process, satellite can go defunct. So what is happening is mitigation efforts. There are two ways of looking at how you can change this debris scenario. One is through regulation using UNOSA or other agencies. Other is mitigation efforts. Now that there are some debris, but we need to do some corrective action. So there are various aspects of doing that. So another thing is perpetual surveillance. You have a ground-based observational system or a space-based observational system by which you are looking at all the objects in space, including functional, non-functional, dysfunctional satellites or debris, and make sure that each and every object is monitored, and we know where they are with respect to what time. So that if you want to launch a new satellite or launch a launch vehicle, we are very clear that what is the right time to go up in space. We are likely to impact or likely to. You see, it is just like a traffic management. Correct, no? When you want to come down to Kochi or Ernakulam, you want to drive down, when would you prefer? When traffic is less, right now. So similarly, if you want to launch into space, in launch vehicle, PSLV mission or GSLV mission or any mission for that matter, you will have to go to the appropriate time where you are likely to face minimal objects in space. So that is why perpetual monitoring is important. Space situational awareness. അതായത് പാരിസ്ഥിതിക അവബോധമാണ്. What is going to happen around me? So that is very important. That has to happen. So voluntary efforts of stakeholders. There is some organization called the Union of Concerned Scientists. That's a very voluntary organization who are studying the space debris situation, etc., etc. They are trying to do the corrective action. So this I will skip. And the most important part is, in the future, whatever satellites we are going to launch, design those satellites in such a way that those by design, you build better systems. Those will generate less of debris in space. Will make more compact launch vehicles. Launch vehicles by design, self-eating. Some proposal is coming. They will crumble and they will damage themselves without creating much of rubble. So those things are there. Spacecraft reliability, we will have to focus on that. And there should be mechanisms on board by which ground-based system will be able to monitor. That means if I am far away in space also, my father should be able to communicate with me and find out where you are all right or where you are moving like that. You understand what I am trying to say? So ground-based monitoring systems have to be in place to ensure that each and every object is being tracked in space. Now the challenges, sustainability is, I would say, the greatest of all the, because if there was time we could have dwelt in detail, but unfortunately we are already falling short of time. So we are coming to the subject of debris. So by definition, the morning that just earlier I asked the question and you answered. Orbital debris is any human-made object in orbit that no longer serves as a useful purpose, including spacecraft, fragments and retired satellites. That means any object in space, man-made, which is no more functional or useful for any exploitation, they are called debris. Okay, a decommissioned satellite is a debris. A non-functional satellite is a debris. One part of the launch vehicles discarded in space is a debris. The debris lingers above the Earth's atmosphere for years until it decays, deorbits, explodes, or collides with another object, thus creating more debris. Understood now? The possibilities of creating further debris. So, if you are, see, what happens is satellites or other objects, whatever we launch, during their mission life, maybe 5 years, 10 years, or 15 years. Those time, as I said earlier, it is being very strictly monitored from the ground in terms of electromagnetic radiation. You keep monitoring it 24/7. Control. If we're going a little bit left, we fire some rockets and correct it, bring back to the normal course. But this correction needs some fuel to be burned. Some rocket has to be fired right now. So the mission life is basically defined by how much of fuel you can carry on board. So after 10 years or 10 years, 15 years, the fuel will get exhausted. Then what happens? It's called debris. When the satellite is not functional, it cannot go. It will drift out of its orbits. Correct now. So you are driving across a road and you are having a steering control. And at the end of the day, when you run out the fuel, what do? You either go off the road and park somewhere and then you abandon. So similar way it happens. So just this, you can see all these are flying in free space. So some of them, if some of the useful satellites who are flying by, if they are hit by these objects, you will be in trouble. So the trash in space can destroy critical satellites. So this is one satellite, you can see. Useful satellites, some of the debris flying by, you can see this satellite can become malfunction. There is something called Kessler syndrome. So you students should just note down this. You heard about this? Anyone? No. Yes. Who is that? Who is that about? So what does Kessler syndrome mean?
Kessler syndrome means when there is so much space in orbit that when there's one collision, it creates so much space with debris in all the other stuff, and that further becomes an even more debris and keeps hitting, which makes space extremely.
Oh, great, very nice. You also all got it? So this is a theory propounded by one scientist called Kessler. What he said was, if we continue to launch satellites into free space, okay, especially the low Earth satellite 2000 kilometers and already it is very much crowded, and our friend Elon Musk is now launching 10,000, 20,000, 40,000 satellites going there. And these satellites, their life is about 5 years. After that, they will become debris or junk. So in this uncontrolled launch of objects into space for commercial exploitation continues, it may so happen that it is a traffic jam. The outer, see, so it will come to a situation there. So Kessler proposed the population of the objects in space, whether it is debris or anything, continues unabated or uncontrolled. There will come a stage where one object will hit another object to break. Sustainable space and sustainable space development is very expensive because you will have to have a lot of new designs, costly designs coming. So it's definitely going to be expensive. Yeah. Okay.
So why can't we use those metals from the satellites which are killed? Why can't we use those metals from the satellites which are killed?
The question is, why can't we use metals from the satellites that are killed? Yeah, actually, see, if you know these satellites are working in free space, there are a lot of harmful radiations like which have already degraded the performances. So why to bring those components and build a new systems? So that is not usable. So that is why the life of space-based systems are limited because of the harmful environment there. So special components, special techniques are used to take the systems out in space. That is why space exploration is very, very expensive. Right. Okay, welcome. Thank you, everyone.